Okay, so this video is on product rule for counting outcomes, and I'm going to do these three examples. But before doing that, I'm going to just explain that very briefly. So, to find the total number of outcomes for two or more events, we just need to multiply the number of outcomes for each event together. So, this is called the product rule for counting, because it involves multiplying to find a product. So when we say that, let's say there are two events and there are n ways of doing the first event and m ways of doing the second event, and let's say the question is that how many ways are there in total of doing the first and second event. So it's just enough to multiply n by n, because we have n ways of doing the first event and n ways of doing the second event, and the product of them is going to be the total number of ways. So now I'm going to show you how we can apply this to questions. So let's start by the first question. It says that on a menu in a restaurant there are 4 starters, 8 main courses, and 3 desserts to choose from. Okay, so these are the, as you can see, these are those number of ways, if you like. And the first part asks that how many different 3-course meals could you have? Okay, so it's saying that different 3-course meals, which means that we need to pick from each of these, because it says that a 3-course meal. So this means that if you want to know in total how many different 3-course meals we can have, it's just enough to say that, okay, so this is question 1a, 4 times 8 times 3. And it's basically, if we work out this one, then the answer is the total number of combinations that we can have, and it's going to be 96. So in total we can have 96 different 3-course meals. Now let's do part B. It says that in a 2-course meal, one of the meals has to be a main course. So it's now kind of restricting our options, because it says that first of all it should be a 2-course meal. That's the first thing we need to notice, and the second thing is that one of them must be a main course. So this means that we are definitely going to deal with this one. And now the question is, how many different 2-course meals could you have? Right. So we can possibly have two combinations. One is having a starter and having a main course meal, and the other one is again having a main course meal with a one dessert. The reason that at both of those I chose the meal, that's because the main basically course is because here has said that one of them has to be from the main course. So this means that it's either main with a starter or main with a dessert. And now the way that we do this question is very simple. So the first case is when we have a starter and a main. So we have 4 options for a starter and 8 options for the main, plus the second possibility, which is one main, from mains, which is going to be 8 options times 3. So that's basically how we do this question, and which gives me 56. Okay, so that's it for the first question. And as you can see, this is not a difficult question at all, as long as you remember and know how to apply the product rule for counting outcomes. Now let's do the second question and see how can we do that. Now in the second question, it says that a combination lock has 5 rotating wheels which can each be set to one of the numbers 0 to 6. So it has a combination of 5 rotating wheels. So two important things. Now it says that in part A, how many different combinations could you set for the lock? Right. So as you can see, this question is very similar to the previous one, at least part A, which says that we have 5 rotating wheels which can each be set to one of the numbers 0 to 6. So we have 5 options here from the event 1, and from the second event we have 7 options. Remember that we are counting 0 as well as one of our options, so between 0 and 6 or 7 numbers. So yeah, in total, if you want to work out the number of combinations, it's just enough to work out this multiplication, which is 5 times 7, 35. So that's it for part A. Now part B says that how many different combinations could you set that only include odd numbers? Right. So again, it's restricting our options, because now we only can have odd numbers. So the first one remains basically the same, because that's basically the number of rotating wheels, which is 5. But now for the second event, which was choosing one of the numbers 0 to 6, since now it says that only odd numbers, so the odd numbers between 0 and 6 are 1, 3, and 5. So we are going to have 3 options. So 5 times 3, which is 15, and that's the answer of the second part. And finally, part C. It says that if you randomly choose a combination, what is the probability that all wheels are set to odd numbers? So the difference between the first and second part with this third part is, in the third part it's asking for a probability. So this is not anymore like the total number of combinations, so we should be very careful about that. And the way that we can do this question is by using the original formula of probability, which is probability is equal to number of favorable outcomes over number of total outcomes. So that's basically the formula that we use for probability. So number of outcomes that we are interested in over number of total possible outcomes. So if we can do this question by using this formula. So it says that if you randomly choose a combination, what is the probability that all wheels are set to odd numbers? So we already worked out that the total possible number of outcomes that can lead to an odd number is 15. So 15 is going to be the number of outcomes that we are interested in, and the total number of possible outcomes is 35, because we worked that out in part A, and 15 over 35 is the answer of part C. And that's it for this question. Right, now let's do the last part, last question. So in the third question, it says that a vending machine contains 6 different flavors of fruit juice. Then Trish buys 4 cans of fruit juice from the vending machine. She says there are 1,296 different combinations of fruit juice I could get. Is Trish correct? Explain your answer. Right, so this question is sort of different from the last two questions, and in this one we need to check if what she's claiming is correct. So it says that there are 6 different flavors of fruit juice, and she buys 4 cans of fruit juice from the vending machine. And now we want to see, we want to check if the number that she's claiming is actually correct. So we can do this question with by using a diagram. So I'm going to divide that to 6 sections. Right. So we said that there are 6 different flavors. So let's say this is her first attempt, and at her first attempt, there are 6 possible flavors, because she still haven't got any type of juice yet. So there are 6 different flavors available. And let's say so she's done her first attempt, and now it's her second attempt. So in her second attempt, there should be 5 possible flavors, because she's already got one of them at her first attempt. So this means that in her second attempt, maximum there are 5 possible flavors. And now let's see, and it just continues. So in her third attempt, at most of 4 different flavors, and at her fourth attempt there are 3, and that's it. Because the reason that I'm not going to continue, it's because here has said that she only buys 4 cans of fruit juice. So this means that we even don't need to keep going, because she's only tried that for 4 times, and there is no need of just continuing. So now I think this should be very similar to you now, because this should be reminding you that thing we said at the start of the video, which was if you have 2 events and there are n number of ways of doing the first event and n ways of doing the second event, it's just enough to multiply them, and which is basically the product rule for counting outcomes. So in this case, we basically have 4 events, and there are 6 ways of doing the first event, 5 ways of doing the second event, 4 ways of doing the third one, and 3 ways of doing the fourth one. So it's just enough to multiply all these numbers, and this gives me 360. And as you can see, so when we are basically trying to buy 4 cans of fruit juice, at most basically what happens is that we can have 360 different combinations of fruit juice. So that's basically what's telling me. And as you can see, this number is not the same as what she got. So this means that she's wrong, and in total we can have 360 different combinations of fruit juice. Okay, so that's it for this video, and if you want to watch more GCSE and A-level related maths, please subscribe for more videos.